Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and I am back with a new tutorial. Presently we are studying Marine Auxiliary Systems. In this lecture, we will first learn about the purpose, location, construction, operation and types of steam traps. Next, we will study the construction and operation of float type steam trap. Then we will study the construction and operation of thermostatic type steam traps. After that, we will discuss the construction and operation of thermodynamic type steam trap. Next, we will learn about the purpose and construction of steam pipe expansion joint. Finally, we will study the purpose and construction of exhaust pipe expansion bellows. Let us now go through each of these topics one by one in the following slides. Purpose, location, construction, operation and types of steam trap. What is a steam trap? A steam trap is a special type of valve which prevents the passage of steam but allows condensate to pass through. Where is it used? It is used at the outlet of the steam heater and works automatically to drain the condensate without passing any steam. What is the purpose of steam trap? The benefit gained with a steam trap is that the steam is contained in the heating coil until it condenses, thus giving up all its latent heat. What if the steam trap does not function? A faulty steam trap can cause reduced heat capacity of the heater. It is equipped with a strainer to prevent blockage by foreign particles, a side glass to observe condensate flow, stop valves before and after the trap for isolation during repair or maintenance, and a bypass valve to manually control condensate flow when the steam trap is out of service or under repair. What are the types of steam traps? Steam traps may be float type, thermostatic or thermodynamic types, which are discussed through the following slides. Float type steam trap. The sketch shows a float type steam trap which tends to discharge the condensate proportionally to the rate of incoming condensate. It consists of a chamber containing a float and arm mechanism which modulates the position of the discharge valve. Condensate enters from the top connection, and as the level of condensate in the trap rises, the valve is opened to discharge the condensate from the outlet. As the discharge valve is below the water line, it employs a venting system to discharge non-condensable gases through a thermostatic element which opens the valve when cooler non-condensable gases are present but closes the valve in the presence of hotter steam. Thermostatic type steam traps. This test shows the bellows type steam trap which uses the expansion of flexible bellows to close the valve. It consists of a flexible bellows B filled with a mixture which boils at lower temperature than that of the steam and attached to the valve B. Condensate enters from the top and leaves from the bottom. When steam enters, the bellows expands and closes the valve. This type of steam trap compensates itself for varying pressures. It may get damaged if water hammer occurs and bursts if subjected to superheated steam. This figure shows a bimetallic type steam trap which uses the expansion of bimetallic strip to close the valve. It consists of bimetallic strips attached to the valve through the spindle. The condensate enters from the bottom, passes through the strainer, flows around the spindle, and finally leaves from the bottom. As the steam approaches bimetallic strip, the temperature increases and deflection of the bimetallic strip closes the valve. This type of steam trap can work over a wide range of pressures without the need for readjustment and can operate satisfactorily under superheat conditions. It is not prone to damage by water hammer or vibration. Thermodynamic type steam trap. This sketch shows a thermodynamic type of steam trap which uses the pressure energy of the steam to close the valve. It consists of a metallic disc which rests on the seat ring when the valve is closed. Condensate enters from A, passes through strainer S, lifts the metallic disc and leaves from B. It continues as long as condensate enters. As the steam approaches, condensate temperature rises and it flashes to steam. Steam pressure acting on top of the disc overcomes the static pressure underneath and starts closing the valve as shown in stage 2. Stage 3 shows a closed valve with steam pressure acting on top of the disc. To start the next cycle, an orifice is provided on the seat ring which reduces the dynamic pressure acting on the disc. If the condensate is present, it gets discharged. Otherwise, the valve closes again. In practice, the trap usually opens after every 25 to 30 seconds and the length of opening time depends on the amount of condensate to be discharged. If no condensate has been formed, then the trap snaps shut immediately. Steam pipe expansion joint. Expansion arrangements in ship's piping systems are essential for absorbing dimensional changes caused by thermal effect and structural movements, ensuring safe and efficient operation. Thermal expansion and contraction can cause pipe bending or buckling, leading to rupture and leakage. Similarly, flexing and twisting of the ship's hull due to wind and waves may cause misalignment, also resulting in pipe damage and leakage. Steam exhaust gas and fuel oil systems on ships are particularly critical because of the wide temperature variation they experience, making expansion arrangements necessary. This text shows the expansion arrangement of a long steam pipe on the deck. The expansion joint consists of a fixed piece connected to one end of the piping and a sliding piece connected to the other end of the piping, thus forming a gland between the inner and outer pipes. The expansion joint forms a stuffing box to prevent the leakage, and the gland is sealed by tacking rings. Packing rings are held in place by the gland cover, tightened by bolts and nuts. The tie bolt used have loose nuts to align the sliding piece, and the gap formed between flange and the nuts provide the necessary expansion allowance. Exhaust pipe expansion bellows. This sketch shows an expansion bellows used in the exhaust pipes of diesel engines. Auxiliary engines use the pulse system of turbocharging, which requires combining exhaust gas from cylinders, usually in two groups. The exhaust pipes between the engine and turbocharger require bellows to compensate for thermal expansion and contraction. Main engines use constant pressure turbocharging, in which exhaust from each cylinder is discharged directly into a common exhaust manifold. Exhaust bellows are installed between each cylinder unit and the manifold. Large exhaust manifolds are built in sections with bellows installed between them, as well as between the exhaust manifold and the thermostatic. The corrugated bellows element is made of stainless steel or inconel to withstand high temperature and the corrosive effect of exhaust gases. The corrugated bellows is attached between the flange ends, allowing compensation for changes in length. The bellows are usually fitted with an inner sleeve, also made of stainless steel or inconel, to protect the corrugations from erosion and flow-induced vibrations. The sleeve also reduces turbulence and pressure drop in the gas flow. From the outside, bellows are protected by a layer of insulation which also minimizes heat loss. When installing bellows, the only critical requirement is ensuring that the correct direction of gas flow. Otherwise, the bellows may crack and cause gas leakage. Bellows should be routinely inspected for early signs of failures. This completes our study of steam traps and pipe expansion arrangements. This book has been written by me and covers all the topics as per Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all the questions that have appeared in the examination conducted by Indian Maritime University. I am sure that the book will help students prepare effectively for exams and also support them in working safely with marine auxiliary systems. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found the tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with the upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.